Hi guys. Okay, so we're on congruent angles and angle bisectors, day 8 notes of unit 1. And we have a warm-up in the beginning here. And remember that it is super duper important that you read the givens, you think about what it means, and you mark what it gives you. And so when it says that SC bisects BE, remember bisects means to cut in half. And so it says SC cuts in half BE. Therefore, BE is the one being cut in half. So when you find BE and you see the two halves of it, you put tick marks on them. Okay. All right. So part A is finished. It says mark your diagram. We did with tick marks based on what we were given. Then part B says to name a midpoint. And if you remember, midpoints are found right in between two tick marks. So C is in the middle of BE, so that this distance here from C to B is the same distance from C to E, making C in the middle, or C is a midpoint. Okay. Part B is done. Part C, T is between B and E. So if I find B and I find E and I look for T, since T is not on the same line as B and E, TB is between B and E is false. C is between, but not T. Okay, C is done. Part D, name two congruent segments. Those are the ones we tick marked. That's what congruent segments are marked with. And so one tick mark is on BC, and it's a segment, so the bar goes over. And the other tick mark is on CE. Okay. And next one up, name angle 3 in 4 different ways. Angle 3. All right, so angle 3 is right here. And this is one side of angle 3. And this is the other side of angle 3. I like to highlight them so I can see what letters lie on those sides of the angle, so I know what letters I can use. Also notice C is right at the vertex. C must be my middle letter every single time. So we'll go ahead and say angle B, C, T. We can also call it angle B, C, but instead of T, go up to I. Okay. We could also name it angle I, C, B. And we can also say angle T, C, B. Notice these ones here are exactly the same letters, but the first and third have been interchanged. And these ones here are the same letters, but the first and third letter were interchanged. Okay. All right, part E is done. All right. Now that we talked about congruent segments, now we have to talk about congruent angles. Okay? They're angles that have the same measure. Okay? Arc marks instead of tick marks are used in a figure to show congruent angles. So for instance, they tell me the one angle has a measure of 15 degrees and another angle, second angle at DEF, has a measure of 15 degrees. So in geometry, they said that the measures of the two angles are equal. And in geometry, if two angles have the same measure, they're equal, then they are also what they call congruent. Okay? And in order to mark congruent angles, we put these little marks in here. And when you see a single mark here and a single mark here, it doesn't matter what the number is. You know that those two angles have the same measure, that they're congruent no matter what their measure. They're both 15 degrees, or they're both 27 degrees, or they're both 33 degrees. Okay? And again, if you use an equal sign or a congruent sign, they're the same to me in geometry. The only one that they're not the same are mathematicians, and we're okay. We're not going to get that specific. Okay? So let's move this up. Let's talk about an angle bisector. We talked about segment bisectors, and now we have to talk about an angle bisector. Bisect is going to be the same exact meaning. It cuts in half, but this time it's cutting an angle in half. So it's a line array that divides an angle into two congruent angles, or it takes an angle and cuts it in half. In our picture, let's go ahead and put an angle in here. And we could go ahead and put a bisector in here. The angle that is right here is going to have the same measure as the angle right here. And so those green arc marks are indicating that those angles are exactly the same. So if this whole angle, and we always like to use brackets for whole, is let's say 46 degrees, then each of these green arc marked angles are 23 degrees. Okay. So that blue ray is an angle bisector. It's cutting the big red angle of 46 degrees into two congruent smaller angles of 23 degrees. In number 1, it says if BD, which is a ray, bisects angle ABC. So let's go ahead and draw angle ABC. And when you draw angles, either make them acute or obtuse. Don't make them right and don't make them straight, because then you're assigning a specific number to them. So I'm going to label this angle A. B has to be the vertex because it's the middle letter up there, C. And then they tell me that there is a ray called BD. So we have B, so it starts there, and it goes in this direction where we can put a D down here. And because it says bisects, this angle will be equal to this angle here. And now they tell us expressions. And angle ABD is 6x minus 2. And angle DBC is 4x plus 18. So we have to figure out, how do we find the value of x? So we have to set up an equation that represents our picture here. Well, remember that this angle is equal to this angle. And this expression represents that angle, and this expression represents that angle. So if the angles are equal, the expressions are equal. And so we will go ahead and set them equal to each other. There is no square term, so we do not have to factor. We do not have to get equal to 0. So we're just going to go ahead and rearrange our terms. And I'm going to subtract 4x, leaving me with a 2x minus 2 equals 18. Then I'm going to go ahead and add 2 and come up here. We have a 2x on the left-hand side equal to 18 plus 2, which is 20 on the right-hand side. One last step, we're going to divide by 2, and x comes out to equal 10. And that is all they wanted to know, is find the value of x. They did not ask me to plug it in. I could if I wanted to check my work. In fact, 6 times 10 is 60. 60 minus 2 is 58 degrees. And 4 times 10 is 40. Plus 18 is also 58 degrees. Okay, and so that's a good double check. All right, question number 2. If ED bisects angle CEB, so again, we're going to start off with an angle, either acute or obtuse, it does not matter. We do not know, but don't make it right and don't make it straight, because then you're assigning either a 90 or a 180 to it. Angle CEB, and then they told us ray ED, so ED bisects angle CB, this red ray cuts this blue angle in half, or into two equal angles, and therefore I'm going to get an equal angle on one side of the ray and an equal angle on the other side. Okay. In this one, they tell me that angle CED, which is this one right here, is x squared minus 4x. That's going to make our problem more difficult. And angle BED is 9x minus 30. Okay. And they want you to find the measure of angle CEB and classify the angle. Basically, they want us to solve for x, plug it in, see what the angle measures, and then be able to classify it as acute, right, obtuse, or straight. And this is the same setup as we had in the last question, where they gave us the one half of the angle and the other half of the angle. We know that these two angles with the green arc marks are equal, and those expressions represent them. So those expressions are equal. So we will go ahead and take x squared minus 4x and set it equal to a 9x minus 30. This time we do have a squared term, and it's a positive squared term, so we're going to leave them there. We know we're going to end up with two answers. We know we're going to have to factor, and we cannot factor unless we're equal to 0. So 9x is going to come on over, and the 30 is going to get added over so that those are opposites of each other, and those are opposites of each other. We're going to squeeze them in here. Okay. We have a square term. There's nobody like him, so he's just going to drop down. We have a negative 4x minus 9x. Negative 4x minus 9x is negative 13x. And then the plus 30 that we brought over. And we are still equal to 0 now. Easy trinomial. We set up our x box. We're going to multiply to that positive 30. And at the same time, add to the negative 13. And we're going to think of the two sets of numbers that work. And we got to be careful because we have 10 and 3, and we also have 15 and 2. In order to get a negative 13 out of 10 and 3, both have to be negative. In order to get a negative 13 out of 15 and 2, 15 has to be negative. Well, only one of these are going to multiply to positive 30. Two negatives multiply to positive 30. This would give you the negative 13 for the add, but it's going to give you a negative 30 for your multiply, and that's not what our X box says. So we will keep our first ones there. Those numbers will do the job, and because it's an easy trinomial, we break them up into as factors. X squared gets broken up into x and x. One gets a minus 10, one gets the minus 3, and we are equal to 0. Then we're going to T-chart. We're going to take this factor out of his parentheses and put it equal to 0. We're going to take this factor right out of his parentheses and put it equal to 0. On this side, we're going to go ahead and add 10, and we end up with x equals 10. On this side, we're going to add 3, and therefore we get x equals 3. Now, geometry and algebra are going to butt heads, and algebra is going to say, we have two answers, but geometry is going to say, no, one of those answers probably isn't going to work out. Normally, one of them is negative, and neither one is negative. So we're going to have to plug in and see which one either makes sense or doesn't make sense. So I'm going to go ahead, just because I foresee, I'm going to look at x equals 3 being the answer. And if I plug in into this expression here, this becomes 9 times 3 minus 30. That's 27 minus 30, which is negative 3. And in this geometry class, we will not have any negative angles. And therefore, I now have a reason to reject this answer of 3. And so I'm going to hope that x equals 10 is my correct answer. But they still want me to find the measure of angle CEB. So I'm still going to now have to plug in my correct answer of 10. So 9 times 10 minus 30 is 90 minus 30, which is 60 degrees. And so this angle here ends up being 60 degrees. Well, I could plug into the other one and hope that I get 60 degrees as well. And I would get 10 squared minus 4 times 10, which is 100 minus 40, which again is also 60. However, I didn't need to plug in because I already knew that those two angles were equal based on how I marked my picture with the equal arc marks and because it says bisects. Okay, so now we got to figure out how big is angle CEB. Angle CB is the whole angle that has two 60s in it. Therefore, part plus part equals the whole, and angle CEB would be 120 degrees. Because angle CEB is 120 degrees and they want me to classify it, it's more than 90 but less than 180, which makes it obtuse. This is an obtuse angle. Even though we didn't draw it as an obtuse angle in the beginning, we didn't know that's how it would turn out, but it is. Okay. All right. So we'll see you on the back side of notes in the next video.